All right, so we're going to talk about interpreting data. This is going to be very important and very useful in science and in math and in English and in your daily lives. It's going to be an important piece to living a well-informed life. Especially, it's very relevant now with our information coming at us with the coronavirus and things like that. We need to be able to interpret the data to make well-informed decisions about how best to live our lives. So this is going to be just kind of an intro into what to pay attention to, especially in regarding the worksheet that we are doing. That is the biggest piece of this. So the first one is the mouse experiment. An experiment studies the effects of an experimental drug on the number of offspring a mother mouse has. 10 female mice are given the drug and then impregnated. The number of mice in their litters is compared to the litters of mice that did not take the drug. So the group A is the amount of mice that the drug has. Group B is the control. So if you're just looking at this, it looks like Group A did really well. And Group B did okay, but not quite as well as Group A. But the thing is sometimes if you just look at it, you're not going to get all of the information you need. So what I think you should best do is find the average of each and then compare the averages of each, because that is going to tell you about how many Group A had and then about how many Group B had. And then you can compare those numbers. If those numbers are within 3 or more different, I think that is significant. So that would tell us if it would work or not. But that is something that you need to be able to analyze and look at, because if you look at 5 and 4, that's really not that much different, especially when they can have 6, right, or 7. So 5 and 4 is not that much different, right? This one even was less than. So this one was the same. So make sure that you're paying attention. This one was way different. So make sure you're paying attention, find the averages, and that's going to be one of our best indicators that the drug worked or the drug did not work. So use your measures of central tendency, mean, median, mode, and range to help you discover if that Group A was actually useful or not. The drug was useful or not. So the next thing is cow growth rate. So here's where we're going to actually have to analyze data and interpret graphs. So we're trying to find feed claims on growth rates. So you have Bessie and you have Bertha, and then you have a table. So both cows ended at the same weight. So you need to figure out if the feed changed the weight, they gained the weight. So what you need to do is it's going to tell you to graph a dotted line for Bessie and a straight line for Bertha. You can use different colors if you want as well. The biggest key indicator is that you need to label the graph. Make sure you include your title, your x-axis, and your y-axis. So your x-axis is probably the month. The y-axis is the weight. This one, it can go either way. Title it. Make sure you have it in the right, which one's going where. And it actually tells you which graph to use. It's a line graph, dotted line and a straight line graph. So this one should be fairly straightforward. So make sure that you're labeling and looking at this. So it's also important to note that they ended at the same weight and they started at the same weight. So the weights in between were not as important, but they still changed. They were pretty close, but they changed how quickly they got there, it appears. So pay close attention to that. So the biggest thing is, I think that everybody struggles with is knowing what type of graph to use. Dotted line, straight line. So this is a line graph or a bar graph versus other types of graph. We need to make sure that we can figure out which best graph to use. So that's going to bring us to figuring out which graph to use. Line graph, pie chart, bar graph. We'll continue that in the next video.